In this presentation, Heidek will explain how to make power plant chimneys better by implementing 5 ideas. These 5 ideas will reduce construction cost, increase power plant efficiency, and improve environmental safety. These are the 5 ideas that will be shown in this presentation. 1. Using an FGD wet stack. 2. Using Heidek's new chimney design. 3. Using the wet-ready guide vane. 4. Implementing a so-called top diffuser. And 5. Placing Heidek's lining system in the 45-degree high-velocity pattern. The first idea is to use an FGD wet stack. Traditionally, many power stations have used reheating equipment to increase the temperature of the flue gas to around 80 degrees Celsius before it enters into the chimney. When using an FGD wet stack, the flue gas is not reheated. It flows from the absorber to the chimney as a low-temperature water-saturated gas flow. Using a wet stack has some very good advantages. 1. No reheater equipment is needed. 2. The ductwork geometry is strongly simplified. And 3. Pressure losses are greatly reduced, minimizing the power consumption in the booster fan. The second idea is to use Heidek's new chimney design. Traditionally, power plant chimneys have consisted of a reinforced concrete shell with a separate internal flue, often constructed in steel. The steel flue carries the flue gas and it is internally lined to protect it from corrosion. The new chimney design does not use any internal flue. Instead, the concrete shell is protected directly using Heidek's block lining system, which is both acid-resistant and strongly insulating. New chimney design or NCD chimneys have an excellent track record for durability and reliability. Using the new chimney design instead of the traditional design has some big benefits. 1. Overall construction cost is reduced by an estimated 30%. 2. Overall construction time is reduced by an estimated 5 months. The third idea is to use a special new type of guide vane, the wet-ready guide vane, for reducing pressure losses and catching harmful acid droplets both at the same time. Traditionally, FGD wet stacks cannot use any guide vanes. Guide vanes would collect droplets from the gas stream and these would then simply be blown back into the gas stream, creating spitting of acid droplets from the top of the chimney. The wet-ready guide vane solves this problem. This new type of guide vane is shaped like an airplane wing, reducing pressure loss in the chimney entry zone by 70%. At the same time, the wet-ready guide vane uses a system of underpressure and slits for catching and draining of droplets from the gas stream, which helps to minimize the risk of harmful spitting. So, using the wet-ready guide vane serves 2 objectives. 1. It reduces chimney inlet pressure losses by about 250 pascal, and 2. It helps to minimize the escape of droplets from the FGD wet stack into the area surrounding the power station. The fourth idea is to construct the chimney with a top diffuser section. This idea was developed by Heidek in close cooperation with its German design partner, Constructure. If we look at a fully cylindrical chimney, we see that positive pressure can develop in the top. The risk of positive pressure is especially great in FGD wet stacks because the flue gas temperature is often close to the ambient temperature, especially in hot climates. Constructure has studied this problem and found that positive pressure can be eliminated by widening the top 15 meters of the chimney under an angle of 8 degrees. This design modification increases draft by 116 pascal, which also helps to drive down the electricity consumption of the FGD booster fan. So, the advantages of the top diffuser can be summarized as follows. 1. The risk of positive pressure in the chimney is eliminated even in hot climates. And 2. The pressure loss in the chimney is reduced by 116 pascal. Or, put differently, the draft in the chimney is increased by 60%, making a 150-meter chimney behave as if it were 240 meters high. The fifth idea is Heydek's so-called 45-degree high-velocity pattern. In any FGD wet stack, the walls are covered with a film of acid condensate, and it is important that this film drains down without being re-entrained into the gas stream, as that would result in spitting of the chimney. In most cases, Heydek linings are applied in a straight, staggered pattern, and the flue gas velocity should not exceed 18.3 meters per second. Once the flue gas velocity rises above 18.3 meters per second, there will be a strong risk of re-entrainment. Cooperating with Alden Research Laboratory in the United States, Heydek has developed the 45-degree high-velocity pattern in which horizontal joints have been eliminated. With the Heydek lining applied in the 45-degree high-velocity pattern, the condensate will drain down safely at much higher flue gas velocities. In fact, no significant re-entrainment will occur up to 22.9 meters per second. The 45-degree high-velocity pattern offers a great solution for FGD wet stack projects where flue gas velocities in excess of 18.3 meters per second can occur. There are three cases where this can happen. 1. Some owners want to convert existing chimneys for use as FGD wet stacks even when flue gas velocity will exceed 18.3 meters per second. 2. Some owners want to create a reserve margin for possible increases in flue gas volume when operating a power plant at maximum capacity or when burning a different coal type. And 3. In some cases, the flue gas distribution in the chimney entry zone is uneven, resulting in localized zones of higher flue gas velocity. Each of the 5 ideas will have its own impact on the construction cost of a new chimney. This slide shows the estimated impact of each idea. For a 600 megawatt unit, the estimated combined effect of all innovations is a savings of well over $4 million. In addition to the savings in construction cost, power plant owners who use the 5 ideas will also enjoy a very significant reduction in operating cost. For a 600 megawatt unit, the combined benefit is estimated to be $1.5 to $2 million per year. Every power plant operator planning to build a new power plant or to fit flue gas desulfurization equipment should consider to use some or all these 5 ideas. By doing so, the owner can reduce construction cost as well as future operating cost and at the same time improve environmental performance.